Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0113, refers to an issue with the intake air temperature, IAT, sensor 1 circuit. This particular code indicates that the output voltage of the IAT sensor exceeds a predetermined value, signaling that there is an abnormality detected by the Powertrain Control Module, PCM. The IAT sensor plays an essential role in monitoring the temperature of the air entering the engine, influencing the air-fuel mixture for optimal combustion and performance. Its precise operation is crucial for fuel efficiency and emissions control. The PCM uses the data from the IAT sensor to adjust various parameters, ensuring the engine runs smoothly. Therefore, it is critical to address any issues related to this sensor in a timely manner to maintain vehicle performance and compliance with emission standards. The Intake Air Temperature Sensor 1, IAT Sensor 1, functions by measuring the temperature of the air that enters the engine via the intake manifold. This information is crucial since it directly impacts the air-fuel ratio that the PCM utilizes to fine-tune engine performance. Located in the intake manifold, the IAT sensor monitors temperature fluctuations to ensure that the PCM can adjust fuel delivery as needed. Elevated temperatures can lead to fuel vaporization, impacting combustion efficiency and ultimately engine performance. If the sensor malfunctions or reports erratic data, the operational efficiency of the vehicle can be adversely affected, leading to poor driving performance and increased emissions. Several potential causes can trigger the DTC P0113. A faulty IAT sensor remains the most common culprit. If it is unable to correctly measure air temperature, it can send erroneous voltage signals to the PCM. Additionally, wiring issues, such as damaged or corroded wires, can create poor connections, leading to incorrect readings. A malfunctioning Powertrain Control Module, PCM, might also misinterpret these signals, leading to stored DTCs like P0113. Open circuit detection can further complicate the issue, indicating that there may be a break in the wiring or connectors that affects the functioning of the IAT sensor. Comprehensive troubleshooting steps are needed to effectively pinpoint the root cause. When the DTC P0113 is set, several symptoms may manifest. The most immediate indication is the illumination of the check engine light on the dashboard, signaling drivers to address the problem. Additionally, drivers might experience poor engine performance, particularly during acceleration, indicating that the air-fuel mixture may not be optimized. Increased fuel consumption may occur as the engine attempts to compensate for incorrect readings, resulting in reduced fuel efficiency. Rough idling can also become noticeable, revealing inconsistencies in engine operation. Recognizing these symptoms can help in promptly addressing the issue, ensuring the vehicle continues to operate smoothly. In the first step of troubleshooting the DTC P0113, begin by turning the vehicle to the on mode, ensuring that electrical systems are engaged without starting the engine. This allows for the diagnostic software and high-definition scanner, HDS, to access real-time data for further analysis. Once in this mode, check the IAT Sensor 1 voltage value displayed on the HDS. If the voltage exceeds 4.92 volts, it confirms the failure and reinforces the DTC P0113 readout. Verifying this voltage provides a critical initial diagnostic step in determining if the issue lies with the IAT sensor itself or another related component. Moving on to the second step, preparation for voltage inspection is essential. Ensure that the mass airflow sensor IAT sensor 1 4P connector is disconnected from its port. This action is crucial to isolate the sensor components and prevent erroneous readings during testing. After disconnecting, utilize a jumper wire to connect terminals number 2 and number 4 of the Math IAT connector. This step will help facilitate accurate measurements of the sensor outputs, enabling technicians to read values directly through the HDS once the vehicle is turned to the on mode again. In this step, using the HDS, check the IAT sensor 1 voltage value once the jumper wire is in place and the vehicle is in the on mode. A normal condition indicates that this voltage should be less than 4.92 volts. If the voltage is found to be within this acceptable range, it suggests that the issue may not reside within the IAT sensor 1, but perhaps with other components related to the system, such as wiring or the PCM. Conversely, if the IAT sensor voltage remains elevated above this threshold, it confirms a fault with the IAT sensor, warranting its replacement or further inspection. The fourth step of troubleshooting involves inspecting the wiring integrity for the IAT sensor and related circuits. Begin by ensuring the MAF sensor, IAT sensor 1 4P connector, remains disconnected. In addition, the PCM connector E 80P should also be disconnected, allowing for thorough inspection and testing. Employ multimeter readings to confirm the ITA1 TE and SG2 wiring conditions. Normal conditions require both of these circuits to show less than 1 ohm of resistance, indicating that the wiring is complete and intact. If readings exceed this value, there is likely a break or failure somewhere within the circuit, necessitating further investigation or repair. In the final troubleshooting step, if the preceding inspection items return normal values, the next course of action is to inspect the PCM for faults. The PCM serves as the brain of the vehicle, interpreting signals from various sensors and managing engine functionality. It is imperative to determine if the PCM itself has developed a malfunction, leading to incorrect communication with the IAT sensor. This may require specialized diagnostic tools. If anomalies are discovered during this inspection, it likely confirms that the PCM is responsible for the DTC P0113 findings, necessitating repairs or replacement for optimal engine performance. After completing all necessary repairs, it is crucial to conduct a final verification of the IAT sensor functionality. Reconnect all disconnected connectors and ensure that everything is secure. Use the HDS to recheck the IAT sensor's voltage values. They should fall within the normal range, below 4.92 volts. Furthermore, clear any stored DTCs from the PCM to ensure that the vehicle's computer resets and returns to normal operating conditions. If the check engine light remains off post-repair and no new DTCs are generated, one can confidently conclude that the issue has been resolved and the vehicle is operating effectively. To prevent issues such as the DTC P0113 from recurring, regular inspections of the intake air system are advisable. Ensure that the IAT sensor and MAF sensor are routinely checked for cleanliness and functionality. It's also beneficial to maintain clean air filters that can affect airflow and air temperature readings. Clogged or dirty filters can lead to abnormal sensor readings and impair engine performance. Keeping wiring and connections free from corrosion or damage will minimize the likelihood of unexpected failures. Adopting comprehensive preventive maintenance can enhance the longevity of vehicle components and sustain optimal engine performance. Conclusively, understanding the DTC P0113 and its implications on the Honda Civic 2022 Plus is instrumental in maintaining vehicle performance. The IAT sensor is vital for accurate air temperature input, which significantly affects engine operations. immediate action against potential issues, including monitoring sensor function and being cognizant of related symptoms, will ensure consistent vehicle performance and efficiency. Through a systematic troubleshooting approach and preventive maintenance, one can effectively reduce the risk of such DTCs arising in the future. Empowering oneself with automotive knowledge will pave the way for swift repairs and enhanced reliability of the vehicle. Please like and subscribe to the channel. See you next time.